Okay. Hello everyone. So today we will be seeing the next part of our adaptive fuzzy, that is nothing but self-organized controller. Now what exactly is a self-organized controller? Fine. We have seen earlier performance measure using here. We have seen membership function tuning using performance measure. So in that case, what was happening was they were tuning the membership function in order to get the better performance, or basically what we say is the performance of the system was assessed and then the membership functions were tuned in order to get the better results. Now this is one step ahead. Okay, now what exactly they are doing, they have a different concept wherein instead of, this is also a performance based system only, so depending upon the performance a corrective actions will be taken so that we get the output in a precise and better manner. But what exactly they are changing? In the earlier case we have seen that they were changing the membership functions, but in this case we are changing the if then rules. So now what happens is, depending upon the performance, the system is going to change the if then rules such that we get the better output. So let us just see the block diagram of the system. Self-organized. Self-organized fuzzy controller. Okay, so let us say that this is nothing but the set point. Set point is basically the reference which is given to the system. This is nothing but our fuzzy controller. This is nothing but the process, and then the output. This is nothing but the feedback which has been coming. Okay. Performance measure. Incremental model, and then there is an adaptive algorithm, adaptation algorithm, and then the output is again fed back to the system. This is the control output U. Okay, this is the error E which is coming from here. Now so this is nothing but the block diagram for the entire system. Now what exactly is happening here is, here let us say that this is nothing but a set point. Set point is basically the reference, and let us say that the reference is 1500 RPM which is required. So this is going to be the 1500 RPM, and let us say this is the process output. Okay, that is the actual output of the system, that is nothing but your 1500 RPM. Let us say we are controlling the speed of a DC motor wherein we want the desired speed to be 1500 constant. So in this case what will happen? 1500 is a set point, you are getting the output as 1500, so the error is what? 0. Okay. Now in this case no actions will be taken because our error is not there only, and thus we need not go ahead with any kind of rectification. But we cannot assure that every time you will be getting 1500 RPM, right? So because there is a variation with respect to the load or voltage, current, anything can be varied, because of which the system can change its speed. So let us say that the speed is something around 1480 RPM. Now what will happen? This 1480 RPM will come back. So as it is a closed loop system, that is the feedback will be given of 1480. Okay, so 1500 minus 1480 is what? 20. Okay, so 20 RPM. So system will come to know that there is an error of 20 RPM. That means what? The speed is mismatched by 20 RPM. Now this can be either positive or negative depending upon the situation. Suppose the speed is 1520, it can be above 1500 also and below 1500. In case of above 1500, the error will be negative. So for negative error, there are certain set of again actions that need to be taken. For positive errors, there are again certain set of actions that needs to be taken. So the overview of what we can say is the system has input and output parameters. There are two input parameters. So input, let us just see. So the first input parameter is error. Okay, and the second input parameter is change in the error. Change in the error. So error E is this, and change in the error is delta E, and the control output is nothing but control output U. So control output is nothing but the output which is coming from our fuzzy control. That is what, so if the speed is 1480 rpm, the control output will say that the speed has to be increased by 20 rpm in order to get the output as 1500 rpm. So that is what is our control output U. So this is having two input and one output type of system. Now let us come to the block diagram. We can see here there are various blocks wherein there is a fuzzy controller. This is nothing but our FKBC block, that is fuzzy controllers. So whatever controlling actions has taken here, the output is given to the process. Process is basically the actual. So if we are talking about a speed control of DC motor, so voltage control or flux control, all these methods will be here. And this is nothing but the actual thing. If we are talking about the speed control, the speed will be the output. This is nothing but the feedback which has been given. Then it is given to the performance measure block. Then there is an adaptive algorithm, and there is an incremental model. Okay. Now, if we compare this with our previous previous topic, what we can see is the block diagram is similar. The only addition in this is there is an incremental block. Now, this self-organized fuzzy control is also a performance-based system. So, depending upon the performance only, this is going to take the actions. But apart from this, there is one more thing called as an incremental model. Now, what is the role of this incremental model? Incremental model is basically a process only. Process model. Okay, so basically what we say is whatever process is occurring here, the same thing has been modeled here. Now, why it is required? Let us say that this is not there. What would have happened? It would have sensed the performance of the system. Let us say that the error is 20 rpm. What it will do? It will take a corrective action. So it will give it to the adaptive algorithm. Fuzzy controller will do all the calculations, and then it will send a control output that the speed has to be increased by 20 rpm. But practically speaking, what happens is you will not get every time. So let us just see here. Let us say the error is here first, 20 rpm. Okay, 20. So the error is 20 rpm. Now what will happen? So first iteration, let us say the error is here, 20 rpm. Now what will happen? It will take an action and it will increase the voltage. So increase the voltage, what will happen? The speed will increase. But practically speaking, in the next iteration, it will never happen to be direct 1500. So what happens is it becomes 1490, let us say. Now what has happened? Again it will sense. So there is an error of 10. This will check the performance. Again improvise. So again it will increase. So like this, like this, like this. And after some time it will come to a constant value wherein the RPM speed will be near to either 1500 RPM, or what we can say, the error will be within our tolerance band such that the system is on the track. But the problem here is we had to go ahead with number of iterations, so go on increasing the iterations. So what they have done in this thing is they have incorporated a process model here. Fine. Now what is this process model? This entire thing, whatever is computing here, it will be computing here itself. Okay, it is a modeling. It has been modeled here itself. So whatever action the performance measure takes. So what does the performance measure take? So it will see to it that it is going to take a control output such that the output is reached in a, or we can say that the best outcome is reached in the shortest possible time. So what is going to happen here is, so let us say that the error was 20 rpm initially. It will be sent to the incremental block. It will calculate and see that if it has been in performance measure, if whatever the actions have been taken here, if it has been incorporated, the speed will increase to 1490 only, and it will give it to adaptive algorithm again. So what exactly this is going to do is, depending upon the performance measure block, so if it will say that, it will say to it that it is 1490 rpm. So it will modify the content, or in this case, what happens is in self-organized, instead of modifying the fuzzy definition, or what we can say is the membership function, now it is going to modify the rules here. So it will modify the rule in such a way that the execution rule in such a way that instead of getting 1490, you will get nearly 1500 rpm or within the band, and then it will give it to the adaptive algorithm, and this output will be given to the process. So what happens is, instead of, so let us say that the error is here only. So instead of computing for this many iterations, now what will happen? So what happens is first iteration, second, third, fourth, fifth. Let us say it is getting computed in the or executed in the fifth iteration. What will happen is second, third iteration you will get the output. So what we have done, we have saved the computational time, and the computational time is very important because we are working on a online system. Fine. So this is nothing but our what exactly is happening with the incremental block. So let us just study here further what exactly is the process and all those things in this part. Next, here as I said you, the system will modify the rules. So let us just take one example how the rules are modified. Let us just see, if error E is very large, and change in the error, that is delta E, is negatively very large, then P is satisfactory. Okay, so what does this rule says? If the error is very large and the change in the error is, if the error is very large, okay, so current situation what it is saying, error is very large and change in the error, okay, is negatively very large, so the output is in the negative side, then the performance is satisfactory. Let us say this was the rule. We'll take one more part. If E is very large and change in the error is very large. Now earlier case it was negative, now it is positive, then P is very poor. So we had this kind of rule, let us say earlier. Now because of this, what was happening was the performance of the system was getting affected. Fine. So what happened was the error was not getting converged easily. So what exactly the system does is it will check the performance of the system with respect to these rules, and it will find out that the error is not getting converged earlier, or what we can say, the error is not getting compensated. So what exactly the system do is, okay, so performance measure block will understand that the system is not getting converged earlier, or the performance of the system is not as per requirements. Thus the system, what exactly it is going to do is the performance monitor block gives the performance in the form of the corrections. Okay, so what exactly the performance measure block will do now? This will, instead of just measuring the performance, what exactly it is going to do is it will give the output in the form of the correction that has to be taken. Okay, so what exactly what we are saying is, suppose that this block, if it was only measuring the performance, let us say that the error is 20, so it will say that error is 20. No, what it will do is it will measure that the error is 20 and it will take a decision, or it will give you a correction factor in order to improvise the error. That means what? From error 20, how can I get it to 0? So what value has to be designed? So that will be given to the next block. Okay, so that is the role of the performance measure block. Thus what exactly, thus the further things what will be done is, in the incremental model and all, it will start changing the rules. So it will change the rule in this way. Okay, if E is very large and delta E is very large, then C is negative very large. Okay, so what we have done, we can see here that earlier it was saying that if E is very large and negative delta E is negatively very large, then the performance is satisfactory. Okay, but what was happening was, with this rule the performance was not getting satisfactory, so the correction has to be taken. So the performance measure block will give a correction factor that it has to be corrected, and thus this rule will be altered now. So the altered rule is, if error is very large and delta is, that is nothing but change in the error, is negatively very large, so this part is similar with this part, then the correction is negatively very large. So the correction factor that requires to be incorporated is negatively very large, and thus your system gets tuned. Okay, so this is one of the examples. Second part what we have seen was if E is very large and delta E is very large, then C is negative. Sorry, C is in the earlier case it is C is very large, and in this case it can be taken as C is negatively very large. Okay, this is just an example wherein we have seen how the rules are modified. So this modification will be done, and then again it will be given to the adaptive algorithm, which will again further send it to the fuzzy controller, wherein it will do all the process and all those things and get the output which is required, that is nothing but U. This output will be such that it will drag the system will drag the output in such a quick manner that it reaches to the constant value within no time, or what you can say, the convergence occurs at a very faster rate. That is what is we see that self-organized fuzzy controller. Okay, fine. Next, the next one what we are going to study is a model based controller. Okay, model based controller is a different concept compared to all these things. Let us just see that thing. So the next one what we are going to study is a model based controller. Model based model based controller. Now again, this is also a self-organized type of system which uses online fuzzy process models for adaptation. Okay, so basically what we can say is this is also this is also a self-organized type of system which basically works on the performance of the system. So depending upon the performance of the system, this is going to take the decisions and all those things. But this system, what we can say, it identifies what exactly is the fuzzy process which has been taking place, and then out of all those fuzzy processes, it gives the system output to the process model and all those things, and then the further computation will be taken. So, but before going ahead, just let us see the block diagram of the model based method. Okay, so process model, performance measure, and then decision making. Okay, so this is nothing but the block diagram for the entire system, wherein the model based controller, the there are three parts in this model based controller. Okay, that is process model, performance measure, and decision making. So this is nothing but the process model, and this is different from the other type of controllers. Now what exactly is happening is there is a process. Process is basically the system which is working. As I said in the previous example also, let us say the DC motor. If your speed is not 1500, so what process is occurring will be identified by the system. Okay, so what we can see here, this fuzzy identifier has an input part from this and output also. So whatever input has been sent will be sensed here, and the output will be sensed here, and then it will compare and check that whether the process is working as per the system or not. Okay, and then there is also a feedback which is given to a decision maker. Okay, now before going ahead, let us, as I said you, this is also a self-organized type of system, which is a performance-based system. Okay, so this is also a performance-based system. So as I said you, depending upon the performance, again the corrective actions will be taken. Now this controller consists of three parts. Okay, so the main focus of the model-based controller is nothing but these three parts. First is nothing but process model, second is performance measure, and third one is nothing but the decision maker. Now, what are the roles of these things? What is a process model? Now, process model is basically, it will consist of the if-then rules. Okay, so the first one what we are saying is process model. What happens is process model takes the decision input from the fuzzy identifiers. That means what? Depending upon what exactly is the system doing and all those things, so that will be given to the process model. So process model consists of if-then rules. Now, what is the role of a process model now? Now, the process model basically has a role of predicting. Okay. Now, how exactly it predicts? We'll come to that part. But the role of a process model is to predict the output. Okay. Now, this block, what we can say is, in a simpler manner, this block, instead of giving you the direct output, what it does is it will predict the output. So we'll just say that it predicts the output, predicts the control output. Okay, this is the output, the process state. Now, how exactly this is going to predict it? Now, prediction is very important. Now, prediction, how exactly it will predict is, depending upon the current situation and the previous situation. Okay, it is going to predict what will be the next output. So that is very important. So this is going to predict the output now. Fine. How exactly? For example, let us just take one example here. Example is, if the concentration of CO2, if the current concentration, if the current CO2 concentration is medium and the previous methane feed rate was low, if the was low, then the next CO2 concentration will be just high. Okay, so I'll just read it once again. If the current CO2 concentration is medium and the previous methane feed rate was low, then the next CO2 concentration will be just high. Now, what do we mean by this thing is, see, the process model, what exactly it is doing, it has if-then rules, and then what it will do, it will predict the output. So what exactly it is doing here is, depending upon the current situation, current CO2 concentration and the previous methane feed rate, so present situation and the previous situation, it is going to analyze it and then give a next decision. So the next part here, So the next CO2 concentration will be just high. So depending upon the current CO2 concentration, the CO2 concentration currently is medium and previous methane feed rate was low. So because of these two conditions, now what has happened here is the next CO2 concentration will be just high. So that is what is it has predicted. So this is the role of the process model. So depending upon the fuzzy identification, so depending upon the process and all those things, this will be given as an input to the process model. Process model, what it will do, it will take the input and then it will process the, what exactly do it will predict the output depending upon the current and previous system, and it will give it to the performance measure block. Okay, so next we'll just see. So the next is nothing but the second block, that is nothing but the controller performance. Okay. Now, controller performance measure. As the name says, what exactly it is going to do? It will check the performance of the system. It will measure the performance of the system. But how exactly it is going to do that thing? Now, here it consists of a group of fuzzy sets. Okay, so now what happens is this performance measure block has a group of fuzzy sets. So let us say that CO2, what we can say is the earlier example what we had taken, wherein what we had said was CO2 concentration. So CO2, we had a fuzzy set of medium, low and all those things. Okay, then for methane feed there are low, medium and high, and then again CO2 concentration just high, medium and low. What different patterns will be there. So such kind of patterns will be here, but these are not the actual ones, or what you can say, these are not the actual system, what we can say, these are not the actual system sets. What is they are there? They are nothing but your required fuzzy sets. Okay, required performance. For example, as I said, we have a system. Basically, it is nothing but the what you can say, a standard table. Okay, so what it says is if the CO2 is 0.8 or if low, then our what you can say, the feed rate should be medium. If the CO2 is high, it should be high. So depending upon that thing, the controller this thing has different types of fuzzy sets. Okay, it has a group of fuzzy sets. Okay, for example, let us say incremental and then decremental type, then there might be a triangular type of function. So there will be different types of fuzzy sets. Fine. Here each fuzzy set describes a required, okay, so each fuzzy set describes the required performance of process. So each fuzzy set describes the performance, that is what required performance. For example, let us just say that the process output has given you a certain output, okay, depending upon the situation. Now this will be fed to the performance measure block. What exactly it will do? Performance measure block, it has n number of fuzzy sets, let us say. So this will be comparing it with the standard one. Fine, let us say this is nothing but the standard, but the actual one what we have received is this thing. Fine. So what has happened now? If I compare, this is 0.7 and this is 1. So required should have been 1, but the value here is, the actual one is 0.7. So this understands that there is an error of 0.3. Okay. So that is what. So it will compare it with the standard one. So required performance was this thing. So required, and this is the actual. So actual will be compared with the required in order to get the, to understand what is the performance of the system. Okay. So depending upon that comparison, now what exactly this will do? This will again predict the outputs. Okay. Predict the output means what? Okay. So the next is what we can say here is, it will predict the output. Okay, so it will predict the output. Now what I have said is, as I said you, there is an error of 0.3. It has understood. So it will, depending upon that 0.3, it will predict an output. Or what it will do is, it will give a certain thing, or what it can say, it will either modify the rule, it will modify the shape of membership function such that we should get the better performance. How exactly it is going to do is, it is going to give you n number of solutions. What n number of solution means what? So in order to get that output improved by 0.3, let us say that the performance of the system is 70% right now. So in order to improve the performance of the system from 70% to 100%, it is going to give you the n number of different options, wherein if, let us say that if the fuzzy set definition is changed by this thing, by this much margin, you will get the performance output. Next thing what it will say is, if you change the rule, this rule, it will get the this output. So there are different indexes or different preferences it will give you. Each preference will be having, or what it can say is, it will give you the ratings for whatever control action has to be taken. So what we can say is, rating is rating 1, rating 2, rating 3. It can be anything, any kind of indices they can be using. So for, if I use if then, change if then rule, then you will get first rating as highest rating. If I change the fuzzy set definition, I will get this thing. If I change the fuzzy set definition of CO2 by this margin, then so n number of ratings will be given depending upon that thing. So the rankings have been given. Rating is basically, let us say that the ranking is given. Now, so you have n number of options now. The controller has. So that is what is the work of decision maker now. So the next part what we are going to see is the decision maker. Decision maker gets all these inputs, okay, from process model, performance measure, and all from the feedback path and all the things. So it gets all the inputs. Then it will check the preferences with respect to the thing here. Okay. Now, the preferences, see, here the role of the, okay, I'll just mention it, next one. So I hope this part is clear, wherein what we can say is, this block will be having the fuzzy set. So I'll just, what we can say, brush it once again. So this control performance block, what it will be having the group of fuzzy sets, and each fuzzy set is nothing but what is required. Okay. So that required fuzzy set will be these things. Okay. Then depending upon the input, whatever has been taken from the process model, what it will do, it will compute the outputs, compare it with the reference, that is nothing but the required performance, and then predict the outputs, and then give the ratings for it. So there will be n number of output solutions which it can use, or it can be provided, and then give the ratings. So that means what, if I go for first one, the performance will be this. If I go for this one, the performance will be this, and then it will be sent for the decision maker. Now decision maker cannot take the decision only on the performance. So what exactly it does is, it takes the decision from the performance measure block. Basically what we can say is, from the process model performance measure, the decision has been taken in the decision maker block. Also the feedback from the actual output has also to be considered. Okay, so that is what is the role of the decision making. So let us see the next part, that is nothing but the decision making. So the third part is, C is decision. Okay. Now, what is the role as I described here? The decision maker, what exactly it will do? It will take the input from process model, performance measure, and then the actual output as a feedback, and then it will take the decision such that the output or the performance of the system is at the maximum part. Okay. The role of the decision maker block is to choose from the predefined finite set of control outputs so as to maximize the performance of the process. Now what I want to say here is, as I said, it gives you the preferences. Okay, ratings has been given. So n number of ratings were given, n number of solutions were given. So depending upon all those, it will choose a particular. So particular decision or particular action that has to be taken so that the output is best or the performance of the system is high. Okay, the control output that produces the predicted process state of the highest performance is selected here. Okay, so what exactly we do here is, as I said you, there are n number of systems, so it will recheck it once again, everything. The system which or the method which gives the best performance will be selected, and then the decision is taken and the output, control output U, is generated and will be given to the process. So process, what exactly it will do, again implement it. As I said, the example with the 1400 RPM speed, required was 1500, your actual was 1480. Okay, so 20 ka error tha, for 20 error all this calculation has been done, and now this control output has been developed, which is given to the process. So process, what exactly it will do, it will increase the voltage by a certain value depending upon the value of U, and see that the output is at the required value, that is nothing but 1500 RPM. This is how the entire system works, or what we can say is this is nothing but our model based controller. Okay, so I hope this is clear with everybody. Okay, so if anyone has any kind of doubts, you can please contact me directly. Okay, so thank you everyone. Thank you.